Hello everyone. In this video I am going to explain about what is constraint, what are the different types of supports, and how to draw the free body diagram and a problem related to this. First we will see what is constraint. If you observe any body in the universe, all the objects in the universe are not allowed to move in all the directions. There will be some restrictions to its motion. So the restriction to the motion in any direction is called as constraint. For example, if you observe this sphere here, now this is allowed to move along positive x, positive y, negative y. Okay. Now if I place some restriction here, now this can't move in the downward direction. That means negative y direction is restricted. So this restriction to the negative y direction we can call as constraint, one constraint. Now this is constraint to move along the y direction. Okay. Next, if I keep one more constraint, something like this. Now this is restricted to move along positive x and negative y. So two constraints are there for this particular sphere. Okay. If I keep one more constraint here, then this is not allowed in the negative x direction also. This can move only in the positive y direction. That means in three directions this is constrained. That means in three directions the motion of this sphere is restricted. That is the meaning of constraint. Now we will see what are the different types of supports and support reactions. First we will see the frictionless support. So here if you observe, the sphere is just resting on the surface, plane surface. In this case you can neglect the friction. For frictionless supports, the reaction always acts in the normal direction. That means two objects are in contact at point A somewhere here, then automatically because of this weight there will be some reaction in the opposite direction. That is according to Newton's third law. Some weight is acting on this means automatically this will give some reaction onto this ball. So that's why you can replace this support with the help of a reaction like this. The support you can replace with a reaction like this. RA is the reaction at point A. That means whenever you are removing the support, you have to replace the support with a reaction. At any point on the circle, the normal direction is towards the center. Okay. Next, this is another type of frictionless support. This bar is resting inside this cylinder. In this case, if you observe here, the weight of this bar is W. This bar is in contact with the sphere at A and B points. So at A point, the normal direction, the reaction will be towards the center. Normal direction means the line joining this point to the center, that is the normal direction. Here the normal direction means the contact point B to the center, this is the normal direction. Get the reactions like this towards the center in the normal directions. Now we will see how we will get the reactions for roller and knife edge supports. For roller and knife edge supports also, here this is the roller support, this is the knife edge support. So here this particular bar is resting simply on this roller and knife edge. A force P is acting in the downward direction. That's why in this case also reactions will be in the upward direction. So here you can get the reactions like this. Replace this supports with reactions in the upward direction. Okay, these are the reactions. Okay. Next, hinge support. Here if you observe, this is the hinge. Hinge means this bar can rotate about this particular point, that is the meaning of hinge. Okay, if you replace this hinge with reaction, here the force is acting in the inclined direction, something like this. This is the roller support. Okay. Now you can replace this hinge with some reactions XA and YA, and here at the roller support you can replace it with a vertical support RB. This is YA, not XB. Okay. The hinge restrict the motion of the end A of the beam AB in both horizontal and vertical directions. Thus there are two independent reactions, XA and YA. This is YA. Some typing mistake, you just assume that this is YA acting on the beam at point A. So that's why here resultant reaction will be in some unknown direction. That's why you can take two components, horizontal and vertical component of this particular reaction. Once you know the Xa and Ya, you can get the resultant reaction Ra. In this way, we have to solve these problems. Next is the built-in support. Assume that this is a vertical wall. Into this vertical wall, this particular member is inserted and fixed rigidly. That means you can't rotate it. That's why it is restricting the motion of rotation also. When the rotation also restricted, then it will produce the reaction in the form of movement. That means here you will get three reactions. That is, it is restricted along x direction, means that is one reaction you will get. It is restricted along y direction, means another reaction you will get. That means Xa, Ya you will get. And it is restricting the rotation also, means movement also you will get as a reaction. So here you will get reactions like this. Three reactions you will get. If you replace this support, you will get three reactions: Xa, Ya and movement. Okay. In this way, you have to replace the built-in support with three reactions. Next one is how to draw the free body diagram. So free body diagram is obtained by removing all the supports. The support may be a roller support or pin support or floor or hinge or built-in support. Whatever may be the support, you just remove all the supports and replace them with reactions. First example is ball on the frictionless ground. Here it is resting on the ground. If you remove this ground, you have to replace that with reaction like this. This is called free body diagram. And one more example is ball touching the wall. If you observe this particular case, this is the wall, this is the ball. So this is suspended with the help of this string and it is touching somewhere here. That means here you will get reaction that will be in the normal direction like this. Normal direction here means perpendicular to the wall. And this particular string will get some tension. The tension also you have to represent in the free body diagram like this. So this is the tension, this is the reaction at the wall, and you have to remove all the supports. This is the free body diagram. Okay. Next example is ladder example. When a ladder is placed like this on the floor and touching the wall, so this particular end A is at wall, this particular end B at floor. Here W is the weight of the ladder and P is the force acting at this particular tip. Then you will get the reactions here at the perpendicular direction like this, and here you will get the reaction in the upward direction like this. These are the reactions. That's why replace this support with reactions to get the free body diagram as shown. You just place the reactions and remove the support. Okay. Next we will see one more example, that is a weighing block. So these blocks are suspended around a sheave or roller like this. Suppose if you want to draw the free body diagram of this, then here you will get the reaction in the upward direction and you have to represent the tension in this string like this. So this is the free body diagram. This is the reaction R, this is the tension in this string. Like this you have to draw the free body diagram for this particular block W1. If you draw the free body diagram for W2, only this tension you will get T. There won't be any reaction because there won't be any support here. That's why you will get only tension for T2. That is the free body diagram of W2. Now we will see one problem. Here the problem is something like this. Two equal loads of 2500 Newton are supported by a flexible string ABCD at points B and C. Find the tensions in the portions AB, BC, CD of the string. So this AB, CD is the flexible string. So here you have to find the tensions in between AB, BC and CD. Okay. You assume these tensions as a T1, T2, T3 like this. Assume tensions in between AB is T1, BC is T2, CD is T3. Okay. Next, now consider the free body diagram at B and C points only. Don't take the free body diagram at A and D because we have only two equilibrium equations, that is sigma x and sigma y. Suppose if you take point B, you will get unknown T1 and T2, two unknowns. We have two equations, two unknowns, we can solve the problem. If you go for this particular point A, here T1 is one unknown, here x component, y component you will get. That means x component, y component and T1, three unknowns you are getting. We have only two equations, that's why you can't solve the problem. So you don't go for this particular A point. Similarly, you don't choose D point also, but because at D point also you are going to get three unknowns. So select B point and C point only. If you select B point, if this angle is 30 degrees, this angle will become 30. If this total angle is 120 degrees and up to here this angle is 90, means this bottom portion of the angle is 30 degrees. Something in this way, you just mark the angles. After marking the angles, you draw the free body diagram like this. This is the free body diagram. After drawing this free body diagram, take sigma fx. Take sigma fx. So sigma fx means sum of all the x components. So if you take T1, T1 is making 30 degrees with vertical axis. When you are taking vertical axis, then this cos component T1 sin 30 will become the vertical y component. T1 sin 30 will become the x component. So that's why, so that T1 sin 30 is towards negative x, minus T1 sin 30 you will get towards negative x. Then if you go to T2, T2 is making 30 degrees with x-axis. That means its cos component will become x component, that is T2 cos 30, which is acting towards positive x, is like this, plus T2 cos 30, that is equal to 0. Okay, this is sigma fx. From this you can get T1, just take this term onto that side, T1 equal to T2 cos 30 by sin 30, you will get this is T1 term. Now take sigma fy. Sigma fy means components along y direction. So along y direction means like this. T1 cos 30. This angle is 30. That's why this adjacent side you have to see like this. T1 cos 30 is the y component. T1 cos 30 y component, that is upwards. That means positive. So here this is in the downward direction. So T2 sin 30 is the y component here. T2 sin 30, that is along the downward direction, that's why minus T2 sin 30 is the y component with respect to T2. This 2500 is in the downward direction, means negative, minus 2500, that is equal to 0. Now you substitute this T1 value here. Substitute the T1 value here in the above equation, then it will be like this. This T1 term you have to write here, the equation will be like this. In this only T2 term is there, take T2 as common, substitute cos 30 sin 30 values and do the simplification. Then you will get T2 value as 2500 newtons. Then you substitute this T2 value 2500 newtons in this equation here. Then you will get T1 value. T1 value is 4330 newtons. Now T1, T2 are known. The other parameter we have to calculate is T3. So T3 is somewhere here. That's why take the free body diagram at point C. Then if you observe here, this angle is 60, means this will become 60. So here equal angles are there with respect to vertical, equal angles are there. Then automatically T2 will become T3, but we will do the problem. Sigma fx we take, then this with respect to vertical angle is there, with respect to vertical angle is there, means x component is sine. So T2 sine 60, that is in the negative direction, minus T2 sine 60, minus T2 sine 60 plus T3 sine 60. This is also with respect to vertical, that's why T3 sin 60, that is in the positive direction, is equal to 0. then T3 equal to T2 sin 60 by sin 60. Sin 60 sin 60 gets cancelled. Then T2 equal to T3 you will get, or T3 equal to T2 you will get. Okay, both are same. In this way you can solve the problems related to. In this way you can solve the problems by drawing the free body diagram. Thanks for watching this video. If you like this video, please subscribe to my channel.